The Arduino Uno is a very versatile little microcontroller that you can make use of for all sorts of different projects. But it isn't the only member of the Arduino family. The Arduino family actually consists of a number of different boards and chips, each with their own specific advantages and disadvantages. Today in the workshop, I'm going to show you some of these different boards and chips and how you can use them in your own projects. So stay tuned and welcome to the workshop. Hey, welcome to the workshop. Today what I'm going to be doing is taking a look at some of the different Arduinos that you can use in your projects. I like to call these members of the Arduino family. Now, the Arduino, of course, is a very common microcontroller device. It's inexpensive and can be used for all sorts of projects, robotics, IoT projects, virtually anything that you can think of, you can build with an Arduino. Now, the most common Arduino is this one over here, the Arduino Uno. The Uno is a very common microcontroller board and very versatile. It's got 14 digital I/O ports plus 6 analog input ports. It has a USB connector on it that you can use both to power the device and to program the device, as well as a power connector that you can connect to a 12-volt supply or to a 9-volt battery. So it makes it very easy to take Uno projects and put them into a permanent enclosure after you're done with them. But there may be reasons that you don't want to use an Uno for your project. You might find that it's too big, or you might even find that it's too small. So there are a number of other Arduinos you can use, and I've got a few of them over here on the workbench with me. Now, on the large end of the scale is the Arduino Mega. The Mega, as you can see, compared to an Uno, is much, much bigger. It's got a lot more digital I/O ports, more analog input ports. It's also got more memory, so it can handle larger programs. So if you find that you're running out of space with an Arduino Uno, you might want to consider using a Mega. Megas are used in large projects. A very common use for the Mega is as the controller board in 3D printers. You'll see a lot of designs that make use of a Mega for that. On the other end of the scale, though, you might want to get a little bit smaller. And this is the Arduino Nano. Now, the Nano is a very versatile device. It's as powerful as the Uno. In fact, in many ways, it's even got a bit more power because it's got 2 extra analog input ports. But as you can see, it's quite a bit smaller than an Arduino Uno. It also has its own USB port, and you can program and develop things on the Uno and then translate your design onto a Nano to get a much smaller part that you can build a smaller device with. If you want to go even a little bit smaller and you don't need the USB port, you can try the Arduino Pro-Mini, and I've got a Pro-Mini here just beside a Nano just so you can compare the size. It's a little bit smaller, and the most notable difference between the two is that the Pro-Mini does not have a USB port on it. You use an external device to program this. There's a lot of times where after you've built the project, you'll never need to program it again, and for that the Pro-Mini is a good choice. Another thing about the Pro-Mini is, in addition to the normal 5-volt version, which is the one I have over here, you'll also be able to get 3.3-volt Pro-Minis, which run at half the speed but take a lot less current. So if you're building battery-powered devices, that can certainly be an issue. There may also be the cases where all the I/O ports that you find on the Arduino Uno or the Nano or the Pro-Mini are not necessary, and what you want is just something that takes very little current and has a couple of I/O ports, and that's all that you need. And for that, we have the ATtiny. Now, as you can see, it's aptly named. It's quite tiny when you compare this to the Arduino Uno, and it doesn't have as many I/O ports as the Uno does. But for a lot of designs, this will be all that you need, and it takes very, very little current, so it's great for battery-powered projects. You may even want to go one step further. The Arduino Uno is actually based upon a microcontroller called the ATmega328. And the ATmega328 chip itself can actually be removed from your Uno after you've programmed it and used in its own design. You just need to add a crystal, a capacitor, and a couple of other support components to it, and you can duplicate the functions of your Arduino Uno on just a single chip. So you can see how this can reduce the size of your designs. If you want to go even one step further, this is an ATtiny chip, the ATtiny85. There's also an ATtiny85. And like its ATtiny board, it has less I/O ports than the Uno does, but it can certainly make for a very small and very low current device that you can build after you've developed things on your Uno. So now that we've sort of done a brief overview of these boards, let's go and look at them one by one. And after this, I'm also going to do an independent article and video on each and every one of these boards, because there are a few idiosyncrasies and design tips for every one of them, and I want to make sure I cover everything. So let's first start off by looking at our friend the Arduino Uno. The Arduino Uno is by far the most popular Arduino board. Literally thousands of projects have been based upon this board, and when you're starting with the Arduino, this is an excellent board to begin with. The Uno has 14 digital input-output pins. 6 of those pins can be used with pulse width modulation for driving things like stepper motors or dimming LEDs. There are 6 analog input pins as well. Uno boards have a USB port. Most of them have a USB Type-B port, but some are available with mini and micro USB ports. The USB port can be used for programming the Uno, communicating with it, and also to supply power to the board. You can also supply power to the Uno through a dedicated power connector, which can take any voltage between 7.5 and 20 volts. This allows you to use a wall-mounted power supply or a 9-volt battery to power your Uno project. Now, the Uno is an excellent experimenter's platform. One of the reasons is that it has a series of connectors on it, which are female connectors that you can simply plug jumper wires into. I've done that over here in my solderless breadboard, and I've got an Uno running the infamous Blink program right now. Now, there are a couple of styles of Unos that you're going to find. This one over here is the one that I really like. It's got the DIP, or dual inline package version, of the ATmega328 on it, and that makes it very easy for you to take the chip out later and use it on a breadboard or on your own circuit board. However, you can also get Unos which have surface mount versions of the ATmega328, and both of them will work fine in your projects. In this case, you just won't be able to remove the chip later on. Now, one of the beauties of the Uno is the availability of shields. Shields are external boards that can connect to the Uno and can expand its capabilities. For example, this shield has a liquid crystal display and a couple of push buttons on it as a keypad, and it just snaps onto the Uno like this and allows you to connect these devices up without having to do any wiring whatsoever. You can also get this very useful shield that I find very handy. This is an I/O shield that allows you to connect stepper motors and potentiometers and switches and things, again directly to the Uno without having to do any wiring. It just simply snaps onto the top. Now, this is a prototyping shield, and this is used when you want to design and build your own shields. Like the other shields, it'll snap on top of the Uno, and it also has space over here for you to do your own wiring, and it's got wiring for some of the more common components. As well, you can take a solderless breadboard and place that onto the shield itself in order to use this as a simple experimenter's platform. It would have worked just great for this Blink circuit, as there only is an LED and a resistor on it, so when you only have a few components, this will work very well. This is another shield that I'm very fond of. The reason is, when I take a shield like this one, for example, and plug it onto my Uno, I don't have access to the connections anymore. Well, I do have access to them over here. I can wire jumpers or things to them, but it's not that convenient for prototyping. This is a prototyping shield, and it fits onto the Uno, and then onto that you'll mount your other shield. And it brings all the connections from the Uno out to these connectors on the side, and that allows you to connect up external devices while still slapping another shield on top. So I find that to be very handy. With the availability of shields and with all the prototyping options, the Arduino Uno is a great board to start off with, and it's great for building projects. But of course, there are other Arduino boards as well. So now let's go and take a look at the Mega. If you're working on a big project, then perhaps you should consider the Arduino Mega. It's by far the largest of the Arduino boards. It has 54 digital input-output pins, and 15 of those pins are capable of pulse width modulation. There are also 16 analog input pins on the Mega. Like the Uno, the Mega has a USB port that is used for both power and communications. It also has the same dedicated power connector, allowing you to use a separate power supply or a battery to supply power for your Arduino Mega projects. Now, as you can see, the Mega is just basically a larger version of an Uno. It's got more I/O ports. It also has more internal memory, so it can handle larger programs. And it's an excellent choice when you want to do something that needs a lot of inputs and outputs, such as a huge array of LEDs, a number of motors, or a bunch of inputs. One nice thing about the Mega is that it's very compatible with the Arduino Uno. As you can see, I'm running the same blink sketch on it and using the same system in which I can just plug wires directly onto the connectors on the Mega. In fact, the very beginning connectors on the Mega, the ones in the top here, are identical to the ones in the Uno. So a shield like this, which is made for the Uno, will also work directly on the Mega by just plugging it into the top half of it. You can also get shields and prototyping boards made specifically for the Mega. This one over here is a prototyping board that again I can just put components on or put a solderless breadboard on and slap on top of the Mega and take advantage of all those inputs and outputs. So if you're looking for something to wire a large Arduino project up, something huge, then a Mega is an excellent choice. However, you might be wanting to go in the opposite direction. The Uno's got all the power you need, but you need something that's a bit smaller, especially for a permanently built project. And for that, we're going to take a look at the Arduino Nano. Now, if you need to shrink things down a bit, you should consider an Arduino Nano. It has the same power as an Uno in a small package. It has 14 digital input-output pins, just like the Uno, and like the Uno, 6 of those pins can be programmed for pulse width modulation. There are also 8 analog input pins, which is actually 2 more than the Uno has. Now the Nano uses a mini USB port. Note that that's a mini port and not a micro USB, which is more common these days. And like the Uno, that port can be used to power the Nano as well as to provide communications for programming and communicating with the device. You can power it with the USB port, and there's also a 5-volt pin on the board that you can use for powering the device in your permanent installations. Now, as you can see, the Nano is a very powerful little package, and it's a great alternative to using an Arduino Uno. There are a couple of things about experimenting with a Nano that are a bit different than using an Uno, though. The first and most obvious is that because of its smaller size and form factor, you can't just plug Arduino shields directly onto a Nano. You can use the shields, but you'll have to wire the pins individually to the respective pins on your Nano. Now, another thing about working with it is prototyping with it. With our Arduino Uno, we are able to use breadboard jumpers to jumper the connectors onto a solderless breadboard. Working with a Nano is a bit different. One way of working with it on a solderless breadboard is simply to plug the Nano directly into the breadboard. I'm personally not too fond of that because I find the pins will deform the contacts on the breadboard, and eventually those contacts won't accept wires very well. Another way is to use male to female cables and just connect the female ends to the pins on the Nano, and that'll work just fine. Although it's a little bit awkward, it's certainly doable. Another way, and the way that I do it, is to use prototyping boards. And I've got a couple of examples of prototyping boards for the Nano over here. This first one here is very basic. It's just got sockets for the Nano, and they're wired out to these pins over here that you can attach wires to. And then those wires can run out to your solderless breadboards or to the sensors or whatever you happen to be using in your project. Another style, the one I've got hooked up here running the blink circuit, is one that I'm very fond of. This one is actually a lot like that shield expansion card that I showed you a little bit earlier for the Arduino Uno. This has all of the pins of the Nano brought out onto these male header pins, along with ground and power pins, and they're arranged so you can plug things like servo motors, potentiometers, etc. directly onto the board. The board also has an onboard voltage regulator and a power supply input, so you can actually use this board as part of a permanent installation, if you wish, in your project. So again, I'm very fond of that board. Otherwise, the Nano can be powered and communicated with using a USB mini cable. Now this is a mini and not a micro USB connector, so be aware of that you'll need to get one of those cables. When you first purchase a Nano, you'll find that it probably didn't come with the pins soldered in. Instead, you're going to get the pins themselves and the Nano, and this is the Nano without the pins. As you can see, it's got components on the back as well as on the front. And you'll have to solder these pins onto your Nano in order to plug it in to your breadboard or to your circuit board or whatever you're doing. However, I suspect that if you're already using an Arduino Nano, then you're very comfortable with soldering, and that shouldn't be a problem for you. So all in all, the Nano is a great alternative to using an Arduino Uno. But you can go a step further. If you think your project is not going to be using the USB port after you program it, and you want something that's even a little less expensive and is actually a tiny bit smaller, then you might want to look at using the Arduino Pro-Mini. The Arduino Pro-Mini is an excellent choice when you're building a project that will seldom need to be reprogrammed in the future. It's a small device, but it still maintains all of the features of an Arduino Uno. It has 14 digital input-output pins, and 6 of those pins can be used with pulse width modulation. It also has 6 analog input pins. What it doesn't have is a USB port. You use something called an FTDI adapter to program this device and communicate with it while you're programming. You can power the device with that FTDI adapter when you're programming it, and afterwards apply power to the VCC pin on the Pro-Mini itself. Now, prototyping with a Pro-Mini is a little bit different than prototyping with the other Arduinos we've looked at. And the reason for that is that the Pro-Mini has no USB port. In order to communicate with the device and also to power it during prototyping, you'll use something called an FTDI adapter. I've got a couple of FTDI adapters over here. As you can see, they've got micro USB connectors on one end and a 6-pin connector on the other end, and that's the end that connects to the 6 pins on the Pro-Mini. You'll also notice perhaps that there's a jumper on this board, and on the back of this board there's a little jumper pad. What that jumper is for is to set the voltage level of the FTDI adapter to match that of the Pro-Mini. The Pro-Mini is available in both 3.3 volt and 5 volt configurations, so you'll need to set that jumper correctly. You certainly don't want to risk applying 5 volts to a 3.3 volt Pro-Mini. Now, like the Arduino Nano, your Pro-Mini will probably come with the connectors not soldered in, and they'll give you a set of connectors, including this little angled connector that you use to connect to the FTDI adapter. Now, the Pro-Mini board itself is quite small and has no components on the bottom side, and so this is a very tiny unit that'll fit perfectly onto a printed circuit board in your project. Now, when prototyping a Pro-Mini, you'll find that you run into the same situation you do with a Nano. You can plug it directly onto the solderless breadboard. Again, I'm not fond of that method. You could use male to female jumper cables simply to jumper to the back of the Pro-Mini itself directly, and that'll work fine. You could also use a prototyping board if you can actually find one. Now, I haven't been able to find a prototyping board for a Pro-Mini. If anyone knows of one, please let me know, because I'd be interested in obtaining one. So since I couldn't find one, I wired one up of my own. I just used a piece of perf board, and I put a couple of female connectors to plug my Pro-Mini into, and a couple of male headers, and I just jumpered them to each other on the back of the perf board, and it works quite well, as you can see here. Now, the Pro-Mini is a great little board. It's powerful, and it's perfect for a lot of projects, but it actually may even be an overkill for a project in which you only need 1 or 2 inputs or outputs. And for that, I want to introduce you to the Digispark ATtiny85 board. Now, the Digispark ATtiny85 board is not actually an official Arduino board. However, it's become very popular in recent years due to its low cost and small size. It's a very small Arduino. It has 6 multi-purpose input-output pins that share the function of being either digital or analog. 3 of those pins are capable of pulse width modulation, and 3 of them can be used as analog inputs. It uses a micro USB port, and that micro USB port can be used to power the device, or you can use the 5-volt pin on the device for power. Well, they say that good things come in small packages, and that's certainly true with an ATtiny. And while that may sound a bit corny, it's actually quite an accurate statement. This little board is very versatile. If you only need a couple of inputs and outputs, this might be all that your project needs. The board that I've got over here is one of 2 styles that Digispark has created. This particular style has a micro USB port on it and a couple of mounting holes, so this board itself can be your entire circuit board for the project. They also make another style in which they've integrated a USB connector, a male connector, onto the side of the board, and you could use that to build a dongle of sorts to plug into a USB port. So again, a very versatile little board. Now, I did not find any prototyping cards for the ATtiny85 board, and I'm not surprised by that. So once again, I've made my own just out of a piece of perf board, and I've wired a couple of wires up to some male headers, just as I did with the Pro-Mini board that I made. And it's great for experimenting. Now, one thing you will find with the ATtiny85 board is that you may need different drivers depending upon the operating system in which you're using the Arduino IDE. The ATtiny85 itself doesn't come with the Arduino bootloader, and there are ways of getting around that. And so I'm going to make a video specifically on working with the ATtiny85, so stay tuned for that. Now that we've looked at all the various Arduino boards, I want to take a quick look at a couple of the chips that actually power the Arduino. And so let's start off by looking at the ATmega328, the heart of the Arduino Uno. The Atmel ATmega328 chip is the heart of the Arduino Uno. Now, the device we'll be looking at is packaged in a 28-pin DIP, or dual inline package. However, it's also available in a number of surface mount packages as well. As you would expect, it has the same specifications as the Uno. 14 digital input-output pins, 6 of the pins capable of pulse width modulation, and 6 analog inputs. The chip runs at 16 MHz when supplied with a crystal, but it can also be used without a crystal to run at 8 MHz. You'll need a minimum of parts other than the crystal in order to create a microcontroller using the ATmega328. Now, the ATmega328 chip is a really great choice when you want to take your Arduino designs and create a custom printed circuit board with them. And you really don't need to add very many support components to make a fully functional microcontroller using the ATmega328. Now, I've taken the ATmega328 out of this Arduino Uno and I've placed it on a solderless breadboard. And with just a bunch of jumper wires and a few components, I've got it running the blink circuit. I've just added a crystal and a couple of capacitors, and you don't even really need those if you're willing to run the circuit at 8 megahertz instead of 16 megahertz. I've also added a 10K resistor and a push button switch, and that's just to provide a reset line. I placed an electrolytic capacitor across the power supply just to reduce any power supply noise, although that isn't even really necessary. The only other component are the LED and dropping resistor for my blink circuit, and as you can see, the blink circuit is running the same on my breadboard as it would on the Uno. Now naturally this brings up one problem. I've now got an Arduino Uno that's missing a chip, so it's essentially worthless. But there is a method that you can use to use an Uno to burn a second ATmega328 chip. And this is great, especially if you want to make several copies of your design. And I'll be showing you that in the video that I do on the ATmega328. So all in all, the ATmega328 is an excellent choice when you want to take your Arduino skills to the max. But there may be several times when you don't need all of the capabilities of the ATmega328. For example, running the blink circuit, I've only actually used one digital I/O pin. And for circuits like this, the ATtiny85 is the way to go. So let's take a look at the ATtiny85 now. Now, if you really want to go minimalistic, nothing will beat the Atmel ATtiny85. The device we're going to be looking at is packaged in an 8-pin dual inline package, but it's also available in surface mount packages. It has 6 multi-purpose input-output pins. 3 of those pins can be used with pulse width modulation, and 3 of them can be used as analog inputs. You don't need a crystal in order to use the ATtiny85. Instead, you program it internally to use an internal oscillator. And you don't even need any other parts with the ATtiny85. You can simply use it on its own. If your design doesn't take a lot of memory and needs very few I/O ports, then an ATtiny85 chip is an excellent choice when you want to take your project and build a final circuit board with it. You don't need any support components to make a working microcontroller out of an ATtiny85 chip. On this small solderless breadboard, I'm running the blink circuit, and the only components I've added other than the ATtiny85 itself have been this LED and resistor for the blink circuit. The Tiny85 didn't need anything, not even a crystal. Now, in order to program my ATtiny85, I used an Arduino Uno as a programmer, and I'll be showing you that technique in the video that I do on the ATtiny85 chip, so stay tuned for that one. Now, I've got that set up over here. The Uno basically is connected to the Tiny85 through a series of jumpers, and again I've added an LED and resistor just so I can test my blink circuit once I've programmed it. The Tiny85 is very easy to program using this method, and another advantage of the Tiny85 is it takes almost no current whatsoever, so it's great for battery-powered designs. So if you want to make a project using your Arduino-based design, make it small and battery-powered, then certainly consider the Tiny85 chip. It is an excellent choice for small Arduino projects. So as you can see, you have a number of different options when you're experimenting with the Arduino. From the all-purpose Arduino Uno to big devices like the Mega to very small boards like the ATtiny85, there's a wide range of Arduino boards, and one of them is sure to be perfect for your project. You can also use the individual chips to make your own circuit boards with your Arduino-based designs. So I hope you found this insightful. As I said earlier in the video, I intend to make other videos for each one of these different boards and chips, and I'll show you experiments that you can do with each of them, as well as the different idiosyncrasies for connecting them up to your computer and working with them. So please stay tuned for those ones. The best way to find out about those videos is to subscribe to the channel, so if you haven't done that already, please do so. And also please visit the website at dronebotworkshop.com, where you'll find accompanying articles for all the videos I do, as well as other projects and tutorials. So thank you very much for joining me. I hope to see you soon in the workshop again. Until then, take care and have fun experimenting with your Arduino.